Awesome. Thank you so much, Cass. We are so excited to kick off another startup showcase here at Capital Factory's Fed Supernova. So today you're going to be seeing 5 companies in the digital engineering space. They'll each have 5 minutes to present and then 2 minutes of Q&A after. So make sure to drop all of your questions in the chat below so we can ask our founders as we go through this 5-company startup showcase. So first, we're going to have Joshua, one of the co-founders of Parasanti, come up and give his pitch first. So Joshua? Awesome, we can see you. It looks like you're on mute.
Yep. Afternoon.
Awesome. So thanks for being here. We're going to just bring up your slide deck and then the stage will be yours.
Perfect.
Awesome. Your 5 minutes begins now.
Awesome. So good afternoon. I am Joshua Seagroves. I'm the co-founder of Parasanti, and we call ourselves the blue collar analytics company. And the reason we call ourselves that is, we're trying to deliver insights and analytics to the extreme edge, where analytics usually, traditionally hasn't been deployed, where limited bandwidth, rough environments, contested environments, and those types of capabilities. So, we work in oil and gas on the oil rig. We work on the farm in the middle of nowhere, as well as some work we have in the DoD where we're, doing these types of image analytics, video analytics, and things like that, in the middle of the sandbox. So, I'm a former Army soldier. I understand that, sometimes you really need that compute out there to make those quick decisions and give you those quick insights, that you traditionally would not be getting from a cloud. Our team is, my co-founder and I both come from, the big system integrators like HP, some of the others out there. But we're all farmers, we're all veterans. We've been in this space for a long time, and so that's why we have that deep understanding. But one of the things that's really compelling about our platform, I believe, is not only this open architecture that we put together and these open data standards, but our partnerships. We usually approach, opportunities with 2 or 3 different partners to be able to bring them in. You may have a partner that does image analytics very, very well, another partner that does video analytics, and having them being able to ride on this platform and this architecture that we've built, really provides an amazing value for the government, we feel. Being able to have not only that platform, but that full DevSecOps approach, that whole CI/CD approach, to be able to get these models and analytics and insights delivered to the edge. And so, you have multiple different components to that. So you have the command and control, you have the underlying architecture, and even some of the cloud capabilities, to be able to take this insight once you've gotten it on the edge and start getting that back to the warfighter or back to the TOC or back to the headquarters. So being able to utilize different communication methods and also different, C2 capabilities that we have. So some of the differences, we don't need a cloud. Our current system runs right on our edge device. It's based off of the NVIDIA platform, but the beauty of this open architecture, it can run on any hardware. Given, it's not going to run on a very, very, very small like ESP32 yet, but it can. So being able to take this architecture, utilize, hardware that you may already have, or cloud resources that you may already have, and really start looking at all that sensor integration. We handle the data integration, the sensor integration, and applying these models, not only from ourselves, but applying these models from our partners. What it does is it really gets us, where we need to be to, bring in these partners to get those insights and those capabilities. So, I'm going to go through this quickly. We do have a edge supercomputer that runs our product suite, as well as the GPU data orchestration capabilities, as well as GPU visualization capabilities. And our GPU orchestration platform also enables all of those partners and those types of capabilities to quickly come in. And I see it on my chat. I'm running over on time, so I'll pause there. I want to thank everyone for today. And my email is joshua@parasanti.com if you have any questions after this or you need some additional information. And I'll stop there for questions.
Awesome. Thank you, Joshua. I'm curious. We have a question in the chat. Tell us about some of your customers. Who is the ideal customer for this product?
Oh, nice. We actually just got a contract with a DIU, which, they had this, they're looking at a capability to detect foreign debris, foreign objects on an airfield, and being able to interface with those radar, LiDAR capabilities, and with our partners bring in that machine learning to detect, foreign debris. That is a great use case for us. And that's something that we're working on right now is it's not just interfacing with the sensors and that orchestration, it's that whole architecture that we're developing. And then all of our suite of partners, we have over 15 different machine learning AI companies that we can bring to this.
That's awesome. Well, I'm glad that you're partnered with our buddies over at DIU. I know they're in the audience, so I'm sure they're giving you lots of in the chat. Thank you so much for joining us. So we're going to bring up our next startup, which is Cougar Systems, and their CEO, Gary, will be presenting. So Gary, welcome on stage.
Thank you for having me.
Thanks for being here. So we're going to bring up your slide deck, and then you are good to start whenever you are ready.
Okay. Just give me the go-ahead that you can see it, and I will get underway.
We're good to go. We can see it.
Alrighty. Well, thanks everyone for being here. Welcome to Fed Supernova. My name is Gary Kurek. I'm the founder and CEO of Cougar. And Cougar is a new type of robotics company. We're building a modular robotics platform. So we're powered by robotics, AI, and IoT, and the platform is called Instablocks. And Cougar seeks to essentially make robotics and automation accessible to anyone, anywhere in the world, enabling breakthroughs in human productivity. So a lot of people ask, what is a robot? And a lot of people think of what you might see on this screen here. To us, robotics is, far more than maybe the traditional media-defined version. We believe robotic machines are much more than that. Anything that really does some sort of physical work. So we tend to define robotics as something a lot broader. We believe that robotics is going to be one of the biggest breakout industries of the 21st century, and I believe it's one of the industries that has the most untapped potential. So if you look at various markets, machine and industrial automation is about $2 trillion today, and subsets of that market, like industrial IoT, industrial robotic arms, is really set to explode in the next 5 to 10 years. In addition to that, there's other mega trends happening. $1 trillion is expected to be spent over the next 5 years, reshoring manufacturing, production, supply chains away from China back to places like the US and Europe. We saw with the whole COVID-19 crisis what happens when you put too much reliance on foreign partners, which have maybe become adversaries over time. We need to be making more ourselves. And this was something that people had wanted to do for a long time, but the straw really broke the camel's back in 2020, and now we're really starting to see that happen. So with all this demand, robotics is not as pervasive as a lot of people would like, and as much as we would like as well. The reason for that is robotics and automation, as we understand it today, is very fragmented. It's a very high-cost industry. It causes customers to buy millions of dollars in machinery, integration, and maintenance costs, and it's really very it's only feasible to a lot of the customers who want it. It's only feasible to like a very small percentage. Typically, the solutions that are deployed are very static, so you don't really reconfigure robotic work cells too much or factory deployments. They're made for very high volume applications, typically for very long product life cycles. And the whole industry as in general is sort of moving more towards customization, smaller batch sizes, faster reconfigurability and things like that. The other thing is that there's a major skilled labor bottleneck. A lot of robotics and automation today has a very high barrier to entry in terms of learning it and understanding it. And globally, there's about 10,000 skilled workers within manufacturing every day that are retiring and are not being replenished at the same rate. And I guess like IoT and AI and integration of so many new emerging technologies into this field is in increasing demand, but is continuing to add complexity to an already very complex system. So even if we just solve technology problems and reduce costs, there's still this human element. You need labor to sort of grow with this industry as it becomes more and more distributed and more deployed. And the skilled labor just doesn't exist there for that. So like as a result, only about 10% of the customers actually want to use automation. This is particularly in manufacturing where automation is used more than in other industries that I think robotics could disrupt in the future. This is actually probably a smaller percentage overall, but the customers who want automation, the vast majority of them don't have access to it. So Cougar sought out about 5 or 6 years ago to sort of solve this problem holistically. This was a massive undertaking technically, but what we did was we created a platform of 30 Lego-like blocks that can be built into nearly any machine imaginable. So it could be, like the traditional robotic arm, but we can also build things like entire CNC mills, modular CNCs, or completely new configurations not feasible until now. So there's several different machine types, literally thousands that we're capable of that this platform can assemble into. So the business models we follow, we have 2 business models. One is a subscription-based robotics as a service model where we're sort of moving away from people having to own machines and having to tie up huge CapEx expenses and buying their own machinery. We can essentially offer robotics as a service, as a subscription. We can upgrade machines on the fly. We can build for one application, change it over to do something else. That's something that automation really isn't set up to do today. And we also have the more traditional model for customers who want to still have all the control and ownership of their own hardware and things like that. But ultimately, we make robotics far more accessible by offering it more as a service rather than having to be this expensive outright purchase. Also, because our platform is only 30 pieces total, no matter what machine you're making, we have a very high economies of scale and a very low cost to our hardware that continues to decrease over time. So what we're sort of trying to do technologically is, back in the 1990s, our desks were cluttered with, single-use devices, phones, stereos, paper calendars, receipt printers. That all essentially got aggregated into a single platform layer, like our phones or laptops, and all those disparate applications became things like software apps. And that's ultimately what we're thinking about for robotics and automation, is to have this one platform that takes many different physical application form factors rather than, say, just a software app. And then more from kind of a business model standpoint, we want to move manufacturing away from like where local server rooms and local networks were back in the .com boom, and more towards the Microsoft cloud type model where everything is moved to cloud computing, making the barrier to entry for starting a web company so much lower. So our early go-to-market strategy has been to sort of own small markets for high pain point problems. That's small to medium-sized companies. And the whole idea is to sort of change the lives of a small group of people in a big way rather than a large group of people in a small way. I think that's a more effective way for starting as a startup and expanding with credibility.
Awesome. Great job. Thank you so much. So we have one question from the audience.
Sure.
Can you tell us about which industries or which use cases is Cougar going after first? What is the most exciting kind of innovation or use cases that you guys are seeing today?
Yeah, so what we're doing right now was actually my next 2 slides. What we've done so far is we've talked to a number of like tier 1 aerospace customers who had issues in building some very large scale metal parts, not necessarily fit for a lot of off the shelf options, in terms of machines you can purchase. So like for the first time, we actually built a completely customized CNC machine around the geometry of a particular part we had to build for a customer. And that was something that we were able to rapidly configure in just a matter of a few hours. So we minimized tool pathways, we optimized for rigidity of the machine. We can build our machines completely in a digital environment so we know how they're going to perform, and that we can take design files, run them through the machines, and basically spit out parts without having to have workers in between that are essentially, programming the CMC, doing the CAM programming, things like that. And as an extension of that, we're also doing similar work or looking to do similar work in the defense sector, where we can build customized machines for high pain point problems. Particularly, we're looking at the Air Force now, where there's a large need for painting aircraft. That's typically a very manual and tedious process. We're looking to do that with automation for many different aircraft sizes and types. That's where the reconfigurability of our solution comes in. And also in areas like supplying retired and outdated like aircraft programs. The average aircraft within the U.S. Air Force is about 30 years old. A lot of suppliers either go out of business. There's something like 10,000 requests every quarter that go unanswered because there's so many like bespoke problems that need to be solved there. So we're looking at applications that have very high pain point that are within a specific niche. Particularly, we're looking at aerospace right now, ultimately. We're just looking to solve these very, very difficult problems within these particular niches first. And that's what we've been doing so far. Yeah.
Yes. Well, Gary, we're excited to see all that you and Cougar do. And thank you so much for joining us today. So next up, we are going to bring up Michelle, who is the co-founder and CEO of 3D Control Systems. So Michelle, welcome to the stage.
Hi, thank you for having me today.
Of course, we're going to bring up your slide deck. So just one moment, and then I'll give you the go ahead and you can start on your 5 minutes.
All right. Tell me when you can see it.
All right, we can see it, and your time starts now.
All right, thank you for having me. I'm Michelle Bachman, CEO and co-founder of 3D Control Systems. We are 3D Control Systems. We've been around since 2014. We developed a desktop 3D printer software workflow that connects 3D printers and design software, and it's called 3D Printer OS. So in the industry, a lot of people know us as 3D Printer OS. We're growing, we're profitable. We have customers like NASA, Google, John Deere, Navy. We're in all the top 50 universities around the globe, like MIT and Duke. However, a few weeks ago, we expanded into the industrial Internet of Things market, or the digital industrial market, with a newly developed platform called ZAP.am. And that platform was built upon 3D Printer OS, but it was purpose-built for the industrial space or the advanced manufacturing space. This is an end-to-end, fully automated workflow platform connecting hardware and software and really driving operational efficiencies for our customers. And so, some of the industry challenges that I've heard and that we've heard being here in the industry are, there's just not a way to connect hardware and software together today in one platform. It's just not easy to use. Traditional manufacturing has been around for so long that they've kind of cracked that nut before. And the costs are really expensive to develop this workflow software for 3D printers or robotics or just hardware in general. And then we have a high level of security. And to have a high level of security, it's very expensive to have that software as well. And then lastly, in advanced manufacturing, there is no workflow today to connect all the systems. It's, you're going in and out of different software packages. You're manually going from three different 3D printers because different OEMs work differently. And there's just no standardization across the board, and there's no operating system. And so those are the three main challenges that we've seen. So how we're solving the challenge is with an end-to-end, fully automated premier software platform called ZAP, like I mentioned. So the way we see this, we're trying to simplify this advanced manufacturing by connecting all these different software platforms and hardware. We integrate the systems, which, you think connect and integrate's the same. It's definitely not. Connecting is just connecting. Integrating is being able to grab the data off of the systems to drive higher quality of the end product or higher quality of the performance of the machine. And then taking all of that and automating it to drive efficiencies for our customers. And again, just making it simple for our customers. And so this is really what it looks like. It's, if you've heard of ERP, MES, CRM, PLM, those are kind of the traditional software packages that businesses use. And some use them in manufacturing and some don't. We've taken the best parts of those different software systems and made those purpose-built for advanced manufacturing. So you can see we start with the design. And within additive, there's CAD, there's FEA, CAE, there's generative design software. All of that software can connect into the workflow, so you're not going in and out of those systems. Then within our platform, we can cost out the part, and we can compare it to different technologies like CNC, different 3D printing technologies within that group, and then determine kind of a best fit for that product. And then you can get a quote. So if you have external customers or even internal departments that you want to get a quote to, you can do that. And then we put the order into the supply chain. And the supply chain in 3D printing or advanced manufacturing is packing, build prep. So there's software that you have to go through many steps to get your parts into the build for a 3D printer, as an example. So you're going through the manufacturing process, you're gathering data off of the machine, you have your settings for the part, and then you go into post-processing and QA as an example for 3D printing, and you're gathering all that information and you're providing that information to customers in a part passport type of manner. So all of it's auditable, and you're able to go back if there's a problem in the field, and you can see exactly what material lot, what operator, what were the settings on the machine, et cetera, et cetera. So all of that is in our platform today. So what is the market that we're targeting? Most of these customers, enterprise, university, government, OEM, they're all driving innovation and production, and they just continue to find themselves spending more money and time than what they had initially thought that they would. And so that's why this platform is really important to help optimize, make it easy to use, take out the cost, and even the time to market. Our 3D printer software platform that we started with is scaled globally. We have 120,000 users. We're in over 100 countries across the globe. We have 50,000 printers connected. We were first to market. We are profitable, and we're still growing. And now, we're pivoting to this new, and I don't even want to call it pivot. We're actually expanding our market into the industrial space. So why us? We've been around for almost 7 years. We've proven this technology out on the desktop side, and we've just built the new platform that is customer specific for them, and we can make it customizable for them. And so we've proven it, we've done it, and we've done the same thing with our clients. We've given them cost savings year over year with our older platform, and now we're planning on doing it with the new platform. We have the most secure platform that's on the market because our company did start out as a security company. We're highly flexible, modular, customizable. So if there's pieces of our platform that customers don't need, take it out and use what they need. And then future-proof. We're here to stay. We've been around for a while. We're just making a move into a new market, and but we've been around for a while, and we're ready to stay and continue to grow. So
awesome job, Michelle. Thank you so much.
Thank you.
So we have a couple of questions from the audience. Some of our folks would love to know, who are your current customers? Who's your ideal customer for this technology?
So right now, with the new technology, we have a pipeline of customers like Lamborghini, GKN, a lot of service bureaus, contract manufacturers are some of our customers. There's also mom pop shops that are some of our customers today that we're working with. So it really spans from big corporations to, very small companies that are just trying to, make a living and grow something out of their garage into something much bigger. And so that's what who our customers are for the new platform. The other platform is Google, John Deere. We've done some pilots with Navy, NASA, and so those are just a few of the customers. And universities. Universities tend to, we're in most major universities.
That's awesome. What use cases and industries are you guys most excited about with your new technology for use cases?
The use cases, it's interesting because it's not application specific. The use case is a company that might be taking and innovating inside the company. So take an automotive company, and they're trying to innovate the next new product using additive manufacturing. But they're doing it all with their internal designers. So their internal designers are sending emails to the 3D printing lab or advanced manufacturing, and you have somebody trying to handle all of these emails. And instead of doing that, you plug them into the platform, you give them access to certain parameters in the platform. They can design and go through revisions on the platform, and then they can actually go through the whole order process, and they can watch their orders their parts being built. So that's one use case. Also external, if one of the companies we just quoted is customers are placing orders with them, and we plug in with their commercial site, and we take the orders from them, and then we take it through supply chain. So it's essentially, like I was saying before, it's like a CRM. So it's managing your customer, giving you insights on how your customer's buying, as well as the design process, and then going into manufacturing and post-processing and delivery. And we tie it all together.
That's awesome. Well, thank you so much, Michelle, for joining us today. Great job. We are going to bring up our next founder, Roman, who is the founder and CEO of AlloSense. Roman, welcome on stage.
Hello.
Hi, we can see and hear you, and we're just going to give a moment for your deck to pop up. Awesome. We can see your deck, so go ahead and get started whenever you are ready.
Sounds good. Hi, my name is Roman Sandoval. I'm the CEO and founder of AlloSense Incorporated. At AlloSense, we design and manufacture advanced asset trackers for military and commercial purposes. I'm presenting to you today as a former RF systems engineer with 10 plus years of industry experience in high volume manufacturing test. And according to Executive Order on America's supply chains, the United States needs resilient, diverse, and secure supply chains to ensure our economic prosperity and national security. There are implications associated with this executive order, such as the complexity of the US supply chain, as well as the complexity and diversification of our defense industrial base. As a small business looking towards this system for integration, we're identifying ways to further integrate and create technologies that align with these various systems and growing complexity. Additionally, modern warfare presents the complicated reality of a multi-domain system of systems solution space. Analysis needs to be continuous and an immersive activity where stakeholders can challenge assumptions in real time. In short, the problem is that mission complexity is growing faster than our ability to manage it. And as a result, we were seeing an increase of mission risk. So digital engineering and a model-based systems engineering approach actually addresses some of these problems. In fact, it adds rapid integration capabilities and increases readiness and adds predictive benefits. As a company trying to further engage with the Department of Defense and also commercial clients, we are strategically aligned with two major strategic capabilities within the US Air Force 2030 Science and Technology strategies. That includes global persistent awareness and also resilient information sharing through our development of what we call distributed sensors, essentially expanding the modalities of sensing to capture all observables. In short, we focus on resilient connectivity and also advanced sensing capabilities. So at AlloSense, we design and manufacture advanced asset trackers and sensors that works indoors and outdoors, has a long battery life of up to 10 years, and has multiple sensing capabilities, sensing temperature, humidity, light, and vibration. Our hardware leverages multiple modes of communication, such as satellite, cellular, and mesh connectivity, which we have a patent on. Moreover, our software is diverse. We have compatibility with web applications, Android and Apple devices, as you can see here on the left-hand side, showing a real-time view and situational awareness across our distributed devices, and also a satellite view. We also have compatibility with the virtual reality and augmented reality headsets. In addition to that, we have compatibility with tactical awareness kits and are continuously pursuing various DoD platforms such as Platform 1. Our approach to further engage with the Department of Defense leverages a model-based single source of truth, where we have additional integration across electrical design models, software design models, mechanical design models, testing methods, and models as well, to then deliver various iterations of our products that align with the contracting objectives. Essentially, what we intend to provide to our major stakeholders is an iterative design and manufacturing release to enable the capabilities that were asked of us as a small business. On the right-hand side, you'll notice the enterprise and distribution effectiveness metrics. This is based on the DoD document for material management. And these are the metrics that we are focusing on improving as we disperse our asset trackers throughout various agencies for the Department of Defense. And so we are also pursuing additional modeling of our sensors through this integrated approach. We'd like to further integrate across onto the JDAC2, AFSIM, and also leverage Platform 1. We are continuously optimizing on enterprise and distribution metrics. All that to be said, my name is Roman Sandoval, and we are Alisense. Sense everything, lose nothing.
Great job, Roman. So one question that we have from the audience is, what is the competitive landscape like for you guys in this industry? Who are your competitors, and how do you guys differentiate yourselves?
Great question. There's various asset tracking technologies already at play. We're noticing that a lot of satellite companies, such as Orbcomm, Inmarsat, Myriota, have IoT devices currently capable of communicating to various satellite constellations already. But that's also a trend that we're seeing. With the new space systems, new constellations that are being sort of made by Starlink, SpaceX, and other nano-satellite constellations, such as Swarm, there's a diversity across these various space constellations. And it's our intent to leverage these different types of diverse constellations to ultimately drive a lower cost product and to have additional multimodal communications platform for sending and receiving data across our sensors. In addition to that, what we're also seeing in terms of competitors are cellular-based trackers. The well-known cellular-based trackers are the Samsara trackers, and also there's the Tile tracker. And Amazon does also have a sort of localized tracker or tracking system as well called Sidewalk.
That's awesome. Well, thank you, Roman, so much for joining us today. We are going to bring up our last and final founder, Sean from Insora. So Sean, welcome to the stage.
Well, thanks everyone. Hi, my name is Sean. I'm CEO founder of Insora. Do you see my screen?
We're going to bring it up just in a moment. We can see your screen and we see your slides. So go ahead and get started whenever you are ready.
Awesome. Insora is a lifetime asset management for telecom, IoT, and infrastructure deployments. To understand the problem we are solving, we have to first understand the wireless landscape. With 4G and generations before that, it was all about personal phones. So we could get away with building a high amount of big towers, what we call macro cells. We have 310,000 of them in the US. With 5G, what's really exciting is real IoT, self-driving, edge computing applications like that, autonomous drones. So now we have to build, because we're using different bandwidths, not only we have to upgrade that existing 310,000 towers, we have to build over 1 million what we call small cells, that are smaller antennas that we build closer to the roads and public property, and also build millions of miles of fiber to basically make that infrastructure happen. Right now, with current methods, this is a huge undertaking. By 2026, our goal in the US was to build 800,000 small cells, upgrade those towers. This translates to a lot of work, and there's a lot of delays. We've only built 86,000 so far. And the reason for it is because even right now in 2021, a lot of this process is manual. Just to put it in perspective for you, in Beijing, China has built 50,000 small cells, whereas in top US cities, we've built somewhere around 700. So like I mentioned, you don't have to read this slide, but the deployment process is extremely complex and very manual more than anything else. So after deploying over 1,100 small and macro cells, we sat down, we collected the data, and we came up with our own solution for InnerSAP with our platform, where we can optimize and design a network for the customer, but also through our combination of apps and softwares, we can automatically generate construction drawings for them, help them track data in the field, see what they're building, and provide continuous support with predictable maintenance and future optimization. Really, the real potential of all the data we collect is translating into something like Google Maps for connectivity. And that's where we show whatever robot or device or car is there, which part of the network basically gives them the most optimum coverage to basically transport. This is just an example of what a part of our platform looks like, so you have an idea. You can send dispatchers to the field, collect the necessary data, and generate the construction drawings and track their progress. Really, what's going on is a lot of manual work. Usually people either hire an engineering firm, or there's an infrastructure owner or turnkey provider that do this internally, or if they really want to save money, they outsource it, but there is no automation for this repeatable process. And because of this, we give a lot of advantage. We do an 8-month process in 2 months. We give extreme savings and maximum coverage to the customer, and we use this data for our work in public property for private networks. We spend over $110 billion a year in the US only in wireless infrastructure. About 50 billion of it goes to the public markets, and 15 billion is what we call deployment, and that's what most of our work is. Just to show you what the customer landscape looks like, you have carriers, but more than carriers, you have infrastructure owners, and that kind of translates to facility owners, campuses, places like that. But you also have telecom service companies, engineering firms that do it for them, and those also use our products. So we started actually last year. We did 140 projects in our first year. This year, we translated into becoming a platform, basically supporting customers with more products. We're on track to do over 500 projects. And this application actually applies to a lot of other industrial markets too. It can be utilities, renewables, or a lot of different IoT devices. Our team has a lot of experience in this field. I have over 9 years of experience in infrastructure. I used to run the 5G deployment for Verizon's biggest vendor in Texas. My brother actually is our CTO. He has over 8 years of designing infrastructure applications for different cities. They're being used widely right now. And we have a team of engineers, customer support that they just didn't fit in here, but they've been extremely supportive throughout the process. So with that, thank you very much. This is my contact information. I'll be happy to answer any questions or anything like that.
Great job. Thank you so much. So one question that we have from the audience is that you mentioned there's some other industries that might be able to use this technology. Can you share a little bit more about that?
Yeah, we actually had an independent study done by us to see what kind of other industries this would apply to. What happens in an industrial world, anything from oil and gas, or anything you want to deploy, like you want to build warehouses or renewable, like solar panels. It's a lot of repetitive process. You first have to go to the field, collect data, translate that in a construction drawing. And when you do construction, you have to update your, basically whatever your database is and your drawing. So for renewables, utilities, we already have some customers in the utility market because fiber is a lot like a lot of our utilities you build. Anything from warehouses, data centers, and places like that, it's the exact same process because we are essentially in the industrial market. We are building things like Legos. It's one module that we repeat 100 times, or there are like 10 modules, and we just put them together and we keep building the same thing over and over again.
Well, awesome. Well, thank you so much for joining us. Great job. Thank you to all of our startups who joined us today for this startup showcase for digital engineering. So I'm going to bring Cass back up to stage and hand the day over to him. So thank you all so much for joining us.